Mm-hmm. Okay. Yeah. So, welcome everyone to the Robotics and Artificial Intelligence Meetup number 49. And in today's session, we have a guest speaker from the robot company, RobCo. The robot company is how it is called. And they are into modular industrial robots. And today, Roman Hölzl, who is the CEO and co-founder of RobCo, will be presenting about building modular industrial robots, and he'll also be doing a demo or sharing a video about one of the robots that they have. So this session will basically, after my introductory presentation, Roman will be sharing his presentation on the topic, which will be followed by a demo, and then you guys would be open to ask any questions to Roman that you have. That would be a small Q&A session, and after that you could stay for your introductions and casual networking. So after the session, this is more optional. So just a quick introduction of what we are doing here. Basically, we are an active learning group of robotics and AI enthusiasts, and we take up a new topic every single week in the domain of robotics or artificial intelligence. And generally what we have is a theme for each month. So for example, last month we had humanoid robots, and before that we had a lot of different themes related to robotics or artificial intelligence in general. So we are a volunteer driven community, which means anyone can actually present their idea, research paper or project. So feel free to participate. To do that, you can check the Meetup volunteer channel or paper reading volunteer channel in the events. Also, these meetings would be recorded and shared online. So if anyone has any problem with the information being shared, or if you want some portion of, let's say, your introduction or anything that you shared being cut off from the video, just message me after the event and I can edit that out. So that should not be a problem at all. And anyone can participate regardless of experience or age. So there are a couple of roles that you can take on the assigned roles channel as well. You can check it out later. So now let's just start. So I'll just hand over to Roman now. So by the way, Roman, did I pronounce your name correctly? It's Roman Hölzl, right? Or how do you pronounce it?
yeah, that's correct. Roman Hölzl.
Okay,
Thanks so much.
Perfect. So over to you, Roman.
Could you give me a quick sign whether you can see my shared screen now?
Just a moment. I think it's still loading for me.
All right.
There are two live being shown on the meeting room, Chandandeep.
Okay, yeah, I'll stop streaming my screen now. Maybe that would help.
Let's see. I'll just stop and share again.
Okay.
How is it? Does it work now?
Yes,
Yeah,
it's working.
it works now. Yep.
Perfect. And can you also see the the animation, or is it just a photo basically?
I think it's just a photo that I can see. Yeah.
Okay. All right. All right. We'll use it anyways.
Yeah. Now the animation is there. Now the animation is there.
Perfect. All right. Yeah. Thanks a lot for the opportunity. I'm one of the co-founders of RobCo, the robot company based in Munich, Germany. And what we do differently, basically, on a high level, is exactly what you can see in the simulation or in the visualization. We are building robots from individual modules, right? So the first truly modular system. And we also assist with a software platform for robot integration. And I'm happy to dive into our thoughts and hypotheses in the next couple of minutes, and then look forward to your questions and also showing the robot a bit. So basically, if we look into the market, the big kind of challenges remain the same, right? So a robotic system typically involves high investment costs. So we're talking about six-figure sums very easily, can be much, much more the more complex the solution gets. So this is one of the high barriers for especially small and medium-sized businesses. The high investment costs are mainly driven by complex integration, right? So you need an expert integrating the system, setting it up, programming it, doing the safety certification. So main part of the high investment cost is basically this project-based cost associated with integration. We then have a system, if it's installed, that's defined by its reach, its payload, its precision. So the use cases are quite limited, right? The use case solution space is basically always defined by those facts that are given by a robotic arm. And then, of course, especially in small and medium-sized businesses that have been set up for human workers, the space that is available is quite limited usually, because it was, basically set up with a human in mind and not for a, basically automated setup. So you always have this kind of like backpack-like setup of a robot having to be integrated afterwards on a machine. So those are the four main hurdles, rendering robotics use especially complex and especially cumbersome for small and medium-sized businesses. And this is exactly what we are targeting with the robot company based in Munich. So if we look at high investment costs here on the left and the limited use cases, our answer to those hurdles basically is to provide much more flexibility in terms of investment through a robotics as a service or leasing program. So there's no need to have that high upfront cost, but basically you can spread out the cost over the lifetime of a robot. We then also have the option to use our RobCo platform to basically optimize the selection of the modules towards a given use case. So we basically don't have the case of limited use cases, but exactly the opposite actually, of where we can combine multitude of modules towards very, very different robot kinematics and thereby expanding through the use cases. And of course, we have the option to not only set up the robot from modules so that it fits a given use case, but as soon as you integrate it and make it fit to a use case, you can always reconfigure it, right, and reassemble it, and therefore set up, for example, a small 2 or 3 degree of freedom robot for a dispensing task, for example, then reconfigure the robot and set up a 6 or 7 degree of freedom robot for a palletizing case, for example. So the way it looks like is basically what I kind of teased in the beginning. So we have those individual robot modules. You can see size M, size L, and size XL, which we have here, ranging from 75 to close to 400 Newton meters. And with that, basically modular construction kit, you can set up various different robot kinematics. That's the one USP we have, basically, differentiated by our technology. And the second one, also tech-driven, is basically our RobCo platform, RobOS, which allows you to pre-program a robot without actually having to program it, and then also very simply set up a robot program live on site at the customer side for very quick integration into an existing use case. Yeah, so we also looked at basically the high investment costs and the not given flexibility, but we also have two more challenges, which is the complex and time-consuming integration and the limited space that is available. And our answer to those challenges, to those problems, is basically to offer the modular kit, which can be retooled and isn't limited to one application, but can be adapted to various different applications. And that system is plug and play, right? So think of Lego or Lego Technic for industrial robots, so fully industrial, performance level D, for example, category 3, so really adhering to all the norms, but with a system that's as simple as a Lego system and plug and play. So how do we start, right? So for example, if you call up on a customer and he or she wants to automate a milling machine, like the one we showed here, what we basically do up front, the first kind of task is we either pull the CAD file from that machine, or if that's not available or very expensive, those can be a couple of €1,000 already just for the CAD file, we just pull basically an environment scan So that's, for example, done with my current iPhone with the LiDAR sensor. We basically scan the environment, scan that machine, and then upload it to our platform. So this is part of RobOS, our proprietary RobCo platform. And then you basically, double-click within the model to basically determine where the robot base should be sitting, where the points would be. Yeah, I mean, this is just a demo, but you could imagine, basically picking up a part here within the machine in here, which is, attached here, and then you basically perhaps, put it there, depalletize it, and then put it somewhere else for a grinding task afterwards. Yeah, very typical task. And then what we do is basically we pull the information, like the coordinates and so on, from those points. And with our proprietary software, we optimize the use of robot modules for that task, right? And so we can very quickly display a robot like this one here, where we say, okay, you need 3 large modules, the large link module here, a couple of smaller modules here in the front, and then with that 5 degree of freedom robot, you can automate that task perfectly, and the price tag for that system can also be calculated straight away. So that's kind of what we do up front, before even being at the customer side, before spending a single dollar on gasoline, on travel time, and so on. Compared to in the industry where we'd go to the customer a couple of times, do some measurements, and so on. We can do all that based in software. And then we basically move up to the customer with a couple of cases, like these ones here, with our modules inside. We then basically set up the robot. Those are the bigger modules, for example, smaller motor modules here. We set up the robot according to our simulation we did before, and basically start integrating and start automating. And I think the solution space is quite vast. Yeah. So if you compare to the given companies in the industry, they sometimes only have like 1 or 3 or 5 different robot arms. We can already, and we're only 2 years old, set up like 30 different arms or even more, given the use case. Yeah, so we can set up load capacities of up to 25 kilos, a robot reach, so robot size of up to 2 meters, more than 2 meters actually. We adhere to the industry state-of-the-art precision of 0.1 millimeters. Maximum speed at the end effector can be around 2 meters per second, can also be much more, yeah, with a large robotic arm. And we have IP54 protection class, if you think of a rather wet environment in a machine, for example. So that shouldn't be an issue. And then we basically, so what we do is we scan the environment, right? We optimize the robot from modules, so we know we need those modules to set up the system. Then we have the suitable robot for the case. So what has to happen now is, of course, the robot programming, right? And I think the one word I said a couple of times already, or the one term, is plug and play. And I think this is exactly what we're doing right here in our programming suite as well. So this is also part of RobOS, of the RobCo operating system. And you basically, the same way you can here specify your tasks with the environment scan, basically here program them, right? So you have a couple of different nodes here which can plug and play into the environment to really simply graphically program the robot. So there's always a start node here. There's, for example, a close gripper node here. Move the robot, open the gripper again, and so on. And by doing that, you can very easily set up a simple task. You can also use nodes for computer vision, sensors, conveyor belts, vertical axes, and so on. And you can also very simply, basically, event-based program the system by just including a sensor here. Say, for example, the pallet has to just arrive before you can start automating. So you read that data out from a sensor, include it here in the interface, and then afterwards start the program as soon as the sensor signal is relevant. Yeah, so that's a small overview of basically, especially the software we're programming and developing to set up the system. And now I think it would be good to kind of zoom out a little bit. So we're basically financed by one of Germany's best-known tech investors, Freigeist Capital, with Frank Thelen, which some of you might know. They just invested this April. We just closed the second round actually of funding this week to boost our growth, and so we're quite well positioned for the next steps. The team is now around 20 people based in Munich. I think we just hit the 21 team member mark this week as well on December 1st, so that's also good. Plenty of work to do, and that's kind of the setup right now. So what do we basically try to achieve with those systems? We want to be much less expensive than the competition, either based on the investment cost upfront, but especially based on the recurring cost during the lifetime of a robot. Yeah? Think of robot as a system and so on. We want to be much faster with the production processes because we can actually optimize the robot to a given use case, and we of course have that maximum level of flexibility by being able to reconfigure the system through the use of our plug-and-play modules. And yeah, that's kind of the setup. We use our systems basically in Germany, Austria, Switzerland, and Poland right now for various applications. We're especially focusing on the 4 main applications you can see here. So machine tending, dispensing of glue, for example, materials handling, like palletizing and so on, and classical pick and place tasks. And you can also, of course, use the system for welding, for quality control, for finishing, and so on. But those are our main 4 applications as of now. And yeah, I think that's about it. So we could either jump into a quick session of questions straight away, or otherwise I'd share a couple of videos we have. I don't know, what should be the setup here?
Yeah, I think we can pause for a quick Q&A session. So if anyone has any questions right now, you can go ahead.
Am I audible?
Yeah, you're audible, Adit.
Hello, Roman. So, very interesting concept. Actually, I'm also presently working on my master's project in something similar to modular robotics. So, you said in your slides that your product is cheaper compared to your competitors, right? So, I would
Yeah.
consider your main competitors would be ABB, KUKA, and even Universal Robotics, those UR arms. So, how does the modularity affect your like? How does it bring down the price of your product compared to theirs? Because like if you compare the laptop like the market, currently there's a company called Framework who's also doing something somewhat similar, like modular. They're building modular laptops, but their pricing is much higher compared to the other existing competitors like HP, Dell, and all those big companies.
Yeah.
So, taking that as a example, how does that how does it translate in your field?
Yeah, thanks a lot. Great question. So basically, there's 2 declinations of an answer here. So first of all, I think the more obvious one is basically you don't always need, because you mentioned KUKA, ABB, Universal Robots, and so on. You don't always need the 6 degree of freedom robot, right? That
Yes.
those companies are offering, especially. So the most extreme example for that would be really a dispensing task on a given level. So dispensing glue, for example, into a box. We've had that case in the past a couple of times. You can actually do that task with only 2 motor modules, right? So if you compare
Yeah.
for 6 motor modules to 2 motor modules, that's a huge difference in price, because the motor modules are the main cost driver for an application. Of course, you need a control unit, you need the links, you need a gripper, and so on. But if you can save on 4 motor modules and perhaps even a link module, that's already a price difference of 5 figures easily. Yeah, so talk about 10,000 euros or more. So that's reason number 1. Basically, just using the modules that you need for a case and not more. And the second reason is basically we don't manufacture individual arms, right? So we basically manufacture individual modules. So
Okay.
as you would manufacture at ABB a 6 degree freedom robot arm, we manufacture 6 individual modules. So you get into the range of economies of scale much quicker.
Okay.
And that's basically the second cost driver, especially over time. And I think besides those 2 main ones, there's even a third one, if you wish. So if you think about practical use cases, you oftentimes need like a linear axis, right, where you place the robot on in order to be portable, or a vertical axis which you set up in order to just push the robot much higher. And that's of course always an external system. That external system has to be integrated by an expert, has to be safety certified, has to be programmed. Perhaps there's a different control unit and so on. And for us, putting in that extra reach might be just an extra seventh module. Yeah. So then, of course, it is a little bit more expensive than the 6-degree of freedom robot, but it's still within one system. Doesn't require external programming or safety certification. So even in those cases, you kind of have that third benefit of less costs as well.
Okay, so it's mainly a factor that the amount of hardware that you're investing on is less, and since it's highly modular, your setup, the time to market is much more reduced compared to other competitors, I guess.
Exactly, less hardware need, less need for periphery in case of basically expanding with individual modules, so less need
Yeah.
of programming and project work, and then also earlier economies of scale, right? Because if you order 6,000 modules, that's cheaper than ordering 1,000 modules, and that's what we do. Yeah, don't order 1,000 arms, but 6,000 individual modules for perhaps 1,000 arms. So that's basically what's working there.
Oh, okay. So my next questions are focused around the docking system. Like your robot arms are meant to be highly modular, right? So there must be some kind of docking technique being used over there. Is that electromechanical or purely mechanical over there?
So you refer to the docking between modules, right?
Different modules,
Between
yeah,
modules, for example. Yeah.
yeah,
Yeah, actually both. So basically, what we have to establish with a given arm is, of course, electricity connection, right? And also a communication protocol. So
yes,
basically, what we have is we have a pin-based system, which basically allows you to plug and play the system together. We have a pin that ensures that the modules are centered, and then we establish communication and voltage connection, and we then basically fix a connection with those red clamps you can see here, right? So we put up
okay.
the motor module here, we then set up this link module here, connect those two, and put the clamp on so that it's fixed, and that's how it works. And we have a hollow shaft, so we use the hollow shaft within the modules to actually establish communication between the modules.
Okay, so it's mainly electromechanical over there, establishing the electrical connections, communication lines, and the mechanical stiffness of that.
Exactly, electromechanical, fixed by a pin within the modules.
Okay. I'm actually working on my master's project now, which involves making a rover that is meant to navigate in different kinds of environments, like on land or water. So
Yeah,
I'm also using the concept of modularity over there to fix different modules in and change it so that the robot can move in different environments. So what
that's good.
kind of yes, thanks. So what kind of literature would you suggest to go through for this to understand these docking systems and understand which would be the best for my use case?
Yeah, perhaps if you just hit me up afterwards via email or via LinkedIn, I can share a couple of docs we use or we used internally, and perhaps
Oh,
they
okay.
might be of benefit for you as well for your thesis.
Sure. Thanks a lot. Thanks a lot.
Okay, perfect.
Yeah.
I have just one question, quick question.
Yeah, Mujib, go ahead.
Yeah.
Yeah, I would like to ask Roman that he mentioned he has like 0.1 precision. Is it like absolute Genauigkeit, or can you just highlight something on that?
Yeah. So basically, perhaps we can also show that in video straight away. You always have to distinguish between absolute precision and repeatability, right? So that 0.1 millimeters is in terms of repeatability, but then that is of course defined by the physical kinematic, right? So if you use a system that's like 2.5 meters large, just physically speaking, with a longer arm, we'll rather be in the range of 0.1 millimeters. For a small arm like this one, which I'm going to show in the video right now, repeatability will be probably much higher. Yeah? I think for this one it was 0.03 millimeters, and I think perhaps this might be a good time to show the video right now. So basically, this is one of the milling machine cases. You'd have a worker there, basically, putting in and putting out the parts, and we then basically took in the robot to automate that. We now started with a bigger arm, right? So we, for demonstration purposes, basically show the reconfiguration right now. So you can now see the clamps here, which a worker would be opening to now, for example, pull off the gripper. Now you can also see the connection pad here, our own electronics, which we developed here for the connectivity. We basically do that for the complete setup, right? Another clamp which you take off to put off that motor module here. And that's the way to basically deassemble or reassemble a system. Yeah, so we now connect the bigger motor modules here. We'd set up the M module here. Now, as you can see, so this is screwed, right? So those are the clamps that are a little bit more, say, robust or used for a longer period of time. The red ones, the clamps here, are basically used, those ones are basically used if you want to set up the robot very quickly, especially for demo purposes and so on. And so now I think we quite quickly showed that the small, like 45 centimeter robot suddenly turned into a 1.30 meter robot with a suction cup on top. And it's good to go for those, aluminum beds here, for example, to put those in and out of the machine. And perhaps a thought on safety. So this application, of course, you can't see any safety fencing and so on right now. But what we typically use is either light curtains to make the application safe, or distance-based sensors, or classical robot cells, whatever is necessary to ensure that the system works safely, but also productively, of course, without harming a human worker. And you can also perhaps show this task here, which we have of using the robot for a dispensing application. So similar setup, right? So we basically used the clamp here to attach this dispensing unit on the robot's end effector. The robot itself, however, is only a very compact 4-degree freedom robot arm, just by basically attaching 4 small motor modules together. So one here, one here, one here, and one here with those clamps, because that's all that's needed to basically 3D dispense glue or grease. I think it's grease in that case here. And
muss. Denn es gibt viele Anwendungsfälle, die einfach mit dem Nutzen der dreidimensionalen Dosierung eben über einen Roboter, der in diesem dreidimensionalen Raum sich bewegen kann, den Kunden große Vorteile bringen, die erst den Kunden dargestellt werden müssen, die man sich so gar nicht vorstellen kann. Das hängt einfach davon ab, was für Produkte der Kunde hat, aber ich habe schon viele Fälle gehabt, in denen ein Bauteil in mehrfachen Stationen dosiert werden musste, da eine dreidimensionale Dosierung nicht möglich war. Also das Ventil konnte nicht im dreidimensionalen Raum bewegt werden. Dadurch musste das Ventil mehrere Stationen durchlaufen, um wirklich alle Dosierstellen zu treffen. Das ist hier in dem Fall, kann man das abkürzen und wirklich an einer Station alle Stellen dosieren.
Alrighty, so this was another video here showing an application. So I think, this would be kind of the end of our presentation here. So I think we already had a couple of questions in between, which is good. So we can now, I think, delve into more questions if you have some. And thanks a lot for the opportunity already. Looking forward to your questions and remarks about the system, about the technology, and so on.
Yeah, first of all, thanks a lot, Roman, for the really amazing presentation. I'm not sure why I'm not able to turn on my video, but anyway, so thanks a lot. I think this was a really interesting presentation, and a few questions that I also had were already addressed before, but so we are now open to any more questions that you have in general regarding modular robots or about RobCo or about his startup journey. Anything you want to ask Roman, basically.
Perhaps I can also take over in terms of question. So, where are you guys joining in from? I saw that you have the RWTH email address, Tanandep. Is that also the case for most of the audience, or what's the setup here?
So it depends actually. So we are from we could do a short introduction as well. We generally do it after the sessions. So it's mixed basically. Quite a few people are from Germany, maybe around Munich or Aachen, or and quite a few people are from US, and also a lot of people are from India. So it's really a mix. We could do a short introduction, but before that, if anyone has any question. You could put right now, otherwise you could also do it with your introductions or something. Okay, I guess we can just start with the introductions, right? So Aditya, let's start with you.
So, hi everyone, my name is Aditya. Currently, I'm doing my master's from UNSW Sydney in the field of robotics. And currently, I'm doing my master's project, and I also have interest in combat robotics, so I'm pursuing that too. Thanks.
Nice. So you're based in Sydney right now?
No, I'm actually staying in India. The flights have not opened yet, right? So the flight situation is a big mess over here.
Yeah.
Once it opens up, then I'll go over there.
I spent like I think 7-8 months at USYD in 2017 in Sydney. Yeah,
Oh,
it was good.
okay.
It was a good time.
Awesome.
Yeah. So let's move to Faizan. Hi, Faizan. I'm not sure if he can hear us. Faizan, can you hear us? Okay. Then let's move to Jignasa.
Hi, I'm a final year computer engineering student. I have worked on some small robotics project and looking forward to work in this field. And I'm from India.
Okay, nice.
Okay.
Welcome, Jignasa. Yeah, and now look, can you also introduce yourself again?
Hi, I'm Lokesh Kumar. I'm basically from India and I'm pursuing undergraduate in mechanical engineering. I'm actually currently I'm working on quadcopters and I'm basically interested in mobile robotics.
Okay, cool. Yeah, thanks for your introduction. I think so. Francisca is actually from RobCo itself, so maybe Francisca, you can also tell us about yourself a bit.
She might be in the lab, perhaps.
Okay. Yeah, no worries. And then Shunya, Ismail, can you introduce yourself?
Hi, I am Ismail. I'm a master's student at RWTH, doing master in robotics and currently looking thesis.
Yeah.
Right.
So he's also in the same course as mine. So he's in Aachen. Yeah, and then Siddhant is someone who also joined very recently.
Hi guys, I'm Siddhant. I'm pursuing undergraduate course in engineering from India, Indian Institute of Information Technology, and really interested in the artificial intelligence domain in robotics. So I'm just kind of exploring out there, and do not have much of experience with it actually.
So you're at the right place,
That's
right?
coming quicker than you think. Learning by doing, I think, is the good motto of this channel anyway. So.
Actually, Roman, I actually wanted to ask you something. Do you does your company work on some vision-based control methods also, or is just a robotic arms seller kind of thing? Like
Yeah.
do you work on that stuff also?
Yeah, we do, but we integrate that from external providers, right? So we really focus
Okay.
on the modularity in terms of mechatronics and hardware, and also on RobOS, our RobCo software platform. And then we, of course, integrate different periphery devices and so on, such as, for example, different camera providers for computer vision, or force torque sensors for forced based control and so on. So this is something we're not basically doing internally in terms of developing it, but we're doing it internally in terms of integrating it.
And also about that control software of yours, what is it based on? That's like based on any free source and built on top of any robotics control framework like ROS, or is it the whole made by your company?
Yep, great question. So it's not based on ROS or something similar, because we need that absolute real-time capability, right? So it's actually something we developed ourselves completely. It's running natively on Linux, and it's a model-based control setup. And we basically did everything from like the low-level Linux setup up until the layers to the graphical user interface. So this is a proprietary technology we developed here at RobCo
That's
over the last
really
years.
that's really impressive. I mean, that was looking really good.
Plenty of long nights, long nights, and plenty of programming hours that went into that. But now it's working fine, and basically allows us to always expand, right? Expand by different motion modes and so on. Yeah.
Yeah. Yeah, thank you. I mean, that was just all.
Yeah, thanks, Siddhant, for your questions. So, Sonelu, can you also introduce yourself? Yeah, actually, with Discord, you can never know, right? There's also sometimes trouble with unmuting yourself. So, yeah, Lucas, I think, can you also introduce yourself?
Yeah, hi, sure. Lucas here, Germany, Hanover. Um, so, as you said before I introduce myself, I am a mechanics engineer, finished. I'm doing now a master next to my work. I work in logistics. We do some robotics and also logistic machine sorter machine. 10 years now of experience. I'm learning now also a lot of software stuff in university next to my job.
Perhaps otherwise, I can also use the time to do a little bit of marketing for RobCo if that's fine.
Yeah,
Basically,
please go ahead.
the one thing I'd like to show you guys. So we talked about a couple of different theses and work you guys are pursuing. So always please feel free to check out our careers page. We have a couple of open positions, much more actually than those that are shown here, in terms of mechatronics, also commercial functions like sales, robot engineering, manufacturing, AI tasks, and so on. So please feel free to check that out. And also, if there are any more questions or anything coming up in the meantime or afterwards, like you before asking about the papers for your thesis, please feel free to hit me up. This is my email address here, or you can also find me on LinkedIn with my name. I'm happy to help out or have someone on the team assist there. And yeah, I think the robotics community is quite a close community, right? So we try to keep it that way. So just hit us up if there's anything coming up we can help you with. Yeah.
Yeah, perfect. Yeah, thanks for sharing that, Roman. I think quite a few people would be interested. So
Sounds good.
yeah. Okay. Yeah. Thanks. Also, Lucas, for your introduction. Now moving to Sachin. Can you introduce yourself?
Hi everyone, my name is Sachin and I'm from India. Currently, I'm preparing for masters.
Okay, perfect. Thanks, Sachin. And then the last one would be Harris. Can you also introduce yourself?
Yeah, sure. Hi, I'm Harris. I'm a middle school student. I'm interested in industrial robotics and a little bit in humanoid.
Yeah. Thanks, Harris. So yeah, these were the introductions. We generally do these introductions always after the session, and then we do just casual discussions. But if you have any further questions for Roman, you can go ahead now because we still have some time. So
Chanda, I can unmute now. I'm
okay,
Alex
perfect. Yeah.
Shonello there. If you want, I can also introduce myself. So I'm based in the UK, and I've just started this year a PhD in robotics. I'm interested in humanoid robotics, and as a matter of fact, I do have a prototype robot that will be used during this PhD program. And I'm mostly interested in control using reinforcement learning of robots with high degrees of freedom. In my case, it's a robot with 22 degrees of freedom. And because it was also discussed earlier here, the robot is based on ROS and uses dynamic servos. So I don't know. Maybe some other time when we discuss humanoid robotics, we can also discuss about this.
Yeah, thanks a lot. I think that is definitely very interesting. We did have the humanoid robots as the theme last month, right? But I'm very open. If you want to share more about your research at some point, just feel free to reach out, and we can also do casual discussions at some point regarding this. Do you also have questions for Roman or about the presentation and the demo today? Alex?
I was interested to know if the modular parts that he presented, they are produced by them internally, or they are subcontracted to somebody else that produces them on order.
Yeah. So, Roman, would you like to answer that?
I think I'm afraid I can only hear you. I cannot hear. I couldn't hear the question before.
Oh,
so perhaps
really?
you can repeat. I'll try to answer.
Okay. Yeah, not sure why that is happening, but yeah. So his question was: so are the modules manufactured totally in-house, or are you also having support from external suppliers, basically?
Yeah, great question. So both actually. So we do buy a couple of basically components. We then do the manufacturing internally. Yeah. So we're buying in the motors, for example, or the gears. There's very specialized companies for those components, and then we of course, but also then develop our own electronics, PCBs, and so on. But we do the assembly and the quality inspection and the commissioning internally here in Munich. We have since the middle of the year also head of operations, which we could gain or could hire from a NASDAQ company, laser company, and she's now heading operations at RobCo. So she basically ensures that everything is manufactured and assembled in time and on budget. And so we're doing that internally. And I think this is also one of the value drivers, because we can very well control the complete manufacturing and assembly process. But of course, it's also a great investment. So that's the answer about that.
Yeah, thanks, Roman. So I have one question also about your funding stage. You mentioned that you are at the second stage. So is it Series A that you are in, or which stage of the funding is RobCo currently?
So we are still a seed staged company. We basically started with the technology transfer grant of roughly €1 million back in 2020, beginning of 2020. And then we raised, so that was kind of a pre-seed funding. We then raised the seed round this April with Freigas Capital and Frank Thelen and his team. And now this week we basically extended the round by 4 more investors, which we had to, which we kind of couldn't take in with the seed round. And we basically now pulled them in and thereby gain a lot more operational support and network for the next stages. And then next year we will probably raise a Series A to double down on growth. So the stage right now is basically still relatively early. Yeah, we're 21 people right now, and we're doing the first customer projects. But then next year we're going into growth phase. So we can actually see that right now we can really handle the customer inquiries we're getting and also build out active outreach at the same time. So we definitely have to invest in growth there. And so this is basically the, kind of the driving force for next year. And so we'll definitely double down on growth there.
Okay, yeah, perfect, got it. And also for the pre-seed round, did you go for Exist? Were you funded by Exist at the starting stage from the university, or some other external fundraisers?
Actually, yes, again, to both kind of. So
Okay.
we had a mix of multiple programs and setups. So we basically had, for example, a grant by the European Space Agency, which a couple of bigger companies in the past have already taken, like Lilium or ESO Aerospace in Munich. We also had a couple of innovation grants and innovation programs. We also had Exist, and we also had prize money, for example, from the TOM Idea competition. So kind of a mixture of multiple programs in the beginning, and now we're basically financed wholly by Freigeist, if you wish, and now extending with the new round this last Wednesday.
Okay, perfect. So multiple sources.
Absolutely, yeah. You could say we have a modular fundraising approach.
Perfectly fitting with the company vision, right? So yeah. So do we have any further questions from someone, so we can have the last set of questions? Yeah, Harris, go ahead.
As I said in the introduction, I am a student. I'm really curious about robotics. So whenever I'm a robotics expert, I just ask whatever questions I get in my mind. I just wanted to ask how do I get started in industrial robotics? You get it
You mean starting to learn, right? So
you're starting to.
yeah, I guess, I mean, so you're still in high school, right? So basically, I think one of the steps is to, of course, take a bachelor in one of the fields that is related to robotics, maybe electrical, electronics, mechanical, or programming, and then do some projects and specialize in one particular area. But the key idea is that it would take some time, and you can even start to do some projects, right, as we were discussing. And I think I can also talk with you personally regarding this and help you with the resources, I think after this, so that should be fine. Yeah,
Thank you very much.
yeah, thanks, Harris.
Roman, you said your company got funding from ESA, right? The European Space Agency.
Exactly, yes.
So from that, I wanted to ask one more thing. Are you making your industrial arms for purposes of running on space in those kinds of application? So, for example, in Japan, there's a company called Gate AI. They are making purely industrial arms for application in space station. So, are you also aiming for something like that?
So basically, not 100%, right? So our focus is really the industry, manufacturing and logistics. But of course, the points you mentioned hold true for our technology, right? So for example, in space, the main cost drivers are weight, right, and volume. And those points we can perfectly assess basically with our modular technology.
Yeah, you will have a major advantage compared to the other competitors.
Yeah, because you don't have to pull up or have to push up complete robot arms, but you can just basically send up a kit of modules, and with that kit of modules you can set up various different robots, rendering the flight much much lighter and much less in volume. However, for space, as you probably know, you have a couple of different requirements which we don't really focus on fulfilling right now, yeah, in terms of certification, IP class, and so on. But it's definitely a very interesting market, and interesting application going forward. So yeah, great remark on that side.
Okay, thanks.
Yeah, thanks, Aditya. So with this, I think we can conclude today's session. Thanks a lot, Roman and Francisca, for arranging this session and for this wonderful presentation. I think it was really helpful, and we learned quite a lot about modular industrial robots and about your work there. And I wish you also all the best for the next funding stages and the more success for all the future endeavors that you would be doing as part of RobCo. So thanks a lot, Roman and Francisca.
Thanks so much for the opportunity. Looking forward to your questions and remarks. Please feel free to reach out via mail or LinkedIn. And great initiative. Thanks so much.
Thank you very much. Yeah, I'll also add your LinkedIn link in the chat room or somewhere. So people can reach out to you. Okay.
All right. Have a great Sunday, everyone. Bye-bye.
Bye.